Hello everyone, my name is Barbara and I would like to welcome you all to our latest Knowledge webinar episode. In this week's episode, RealFlow 2015, Quality, Control and Speed. In this webinar, Luis Miguel Mora will be showing and demoing the latest features for RealFlow 2015, from the use of the new diverso solvers, Spreadsheets, Crown Daemon, Spline nodes to the openVDB meshing and Hybrido improvements. He will also be sharing some RealFlow tips and tricks. Luis Miguel Mora, RealFlow product specialist at Next Limit Technologies, has been sharing his RealFlow expertise with customers for almost 10 years, providing support to major VFX companies all over the world. He is perhaps best known for his RealFlow blog, Luis Miguel Mora, in which he publishes RealFlow tips and tricks. Before we get going, here's an overview of what we do at Knowledge. Knowledge is one of the largest online stores for design software. We offer a huge assortment of software solutions that cater to virtually every designer's needs. Here on the page, you still see our page with RealFlow 2014 that will be updated as soon as the new version is out in a few weeks. Knowledge is one of the largest online design stores. I said that. Remember to follow us on Facebook and follow our blog. We're also on Google Plus and Twitter. Coming up tomorrow in a special presentation, Autodesk Mythbusters, all you ever wanted to know about Autodesk new subscription model. Here's your opportunity to separate the myth from reality. Last but not least, today's webinar is free and is being recorded live. If you want to rewatch this or any webinar episode in our collection, just head over to Knowledge's YouTube or Vimeo channels. And now, without further ado, I'm going to pass the screen to Luis Miguel and make him the presenter so he can dazzle you with his presentation. Let's see, Luis Miguel, you'll be prompt to share your screen.
Okay.
Okay, we see it. What can I say? Vamos.
Okay. Okay. Thank you, Barbara, and thank you everyone for your time. It's Luis Miguel, part of the RealFlow team and RealFlow specialist and technical support at Next Limit. Sorry, I'm going to try. Okay. Okay, so let me tell you that in the RealFlow team, we are very ambitious about what we do, and for that reason, each RealFlow version tries to always improve the previous one, but always keeping in mind an easy way to control fluids. So, in order to help you in that task, RealFlow 2015 includes a bunch of new features as user interface enhancements, follows for demons, Spreadsheets, splines, possibility to add text as a spline or geometry, Crown Daemon, a robust method for computing geometry distant fields, and a better integration with Maxwell, an amazing openVDB measure which is really faster than the previous measure we had for RealFlow 2014, and of course diverso. So we are curious about what diverso means. So what is diverso? Diverso is a new way to make fluid simulation on a small and medium scale inside RealFlow. So it means two new solvers, a new SPH and PVD solver, rewriting from scratch and working also with GPU, where the time simulation have been speeding up considerably. So let me show you a proof. Okay, can you see the video? Okay, this is a scene we simulate in RealFlow 2015 with the legacy SPH and next with the new SPH and PVD solvers. Okay. For the legacy SPH solver, this simulation took 32 hours to simulate. And however, for the new SPH solver, only took almost 9 hours to simulate. And the new PVD solver, only 4 hours for the same simulation. Okay? This is amazing because it means that a scene simulated in hours with the SPH solver in previous version of RealFlow now can be simulated in minutes. But how it works? I'm going to open RealFlow. Okay, it's this one. Okay, this is RealFlow 2015. Okay, the setup for diverso is very simple. We need to create a domain here, okay, and we need to create the domain and choose what kind of solver we are going to use, okay, and then we need to create a sun emitter and connect with the domain so it can emit. Okay, so I'm going to simulate the scene. Not saving. Okay. Okay. Also, the same thing. If we want to add some geometry of Daemon to diversos, if we want to interact with geometry or demons, we need to create maybe a torus. Okay. I'm going to reset the scene. I'm going to create a gravity. Okay, and connect with the diverso domain. So, like Hybrido, the geometry for diverso has the same concept of inside outside. Okay, if we want that diverso collides with the geometry, we need to check if that geometry is solid inside or outside. Okay, I'm going to simulate it again. Maybe I'm going to move the gravity. Okay, this one. Okay. Here we go. So now you see how diverse particles are colliding with maybe a bit bigger particles. Okay. Domain. Display. 3 points. Okay. Of course, we can add all emitters we want to work with diverso. So I'm going to create another emitter for diverso, maybe a square. I'm going to rotate the emitter, and I need to connect it with the diverso domain, so we can interact with the geometry. As I said before, if we want to emit inside the geometry, we need to check that geometry as solid outside. Maybe I'm going to remove the square, it's not necessary anymore. Okay. And simulate. This one. Okay. Very cool. And you have the possibility to, for diverso, to connect, to check the GPU, reducing considerably the time of the simulation. If we go to the diverso tab here in the simulation options, we can use the GPU and choose the graphic card we want to use for this simulation. Okay. Now the simulation will be faster. Okay. Also, a very good thing with diverso emitters, we have the possibility to change what kind of emitter is from their parameters. Okay, here we can. I'm going to hide. We have the circle emitter here. I'm going to change, for example, to a square and simulate again. So it's not necessary to create another emitter for emitting particles if we want to use the same emitter. Okay? So let me show you a proof with diverso. This one. So diverso can also handle millions of particles very fast, modifying the resolution here. Okay, now it's PDB and the resolution is 3000. Okay, for this scene, I'm going to show you the particles. Okay. For this scene, the fluid have been simulated only with one domain and 3 circle emitters, with up 22 millions of particles for the last frame in few hours. Okay, using GPU in this case, it took almost 8 hours. Okay, I'm going to show you the video for this one, and this is the final simulation. Okay, it's cool. Very cool. With the legacy SPH solver, this thing would be almost impossible to simulate due to the machine requirements to get so many millions of particles. Okay, and diverso has a lot of improvements for simulating fluids in a small or medium scale. So once you know what is diverso, I mean, you know, it's a group of new solvers inside RealFlow for a small and medium scale. You need to know what diverso could include. You know that diverso could include more solvers in the future. But this is important. You understand the difference with Hybrido, because Hybrido is large scale and diverso is small and medium scale. Okay. Okay. I'm going to reset the scene. Sorry, I listening some noise in my headphones. I don't know what it is, but it's noisy. Okay. Another big improvement in RealFlow 2015 is the possibility to create splines. Create splines from the new Spline stuff. Also, the diverso spline here, or the Daemon spline, or the legacy SPH spline, it's based on the spline node. Okay, I'm going to create a spline. I select the spline, edit with the edit button here or here. So I'm going to create a new spline. And now I can, for example, create an spline for diverso and copy a spline with it before. Okay. And now, if I simulate the scene, I'm going to simulate the scene, which is very fast. If I check the GPU, it will increase the velocity for simulating. Okay. Okay. Even we can add a shader, for example, connect with the domain. Okay. Okay. You see, it's very fast. Diverso is very fast simulating. So and also we have the possibility to import a spline from SVG format or creating a spline from text for diverso daemons or SPH or legacy SPH. Okay, I'm going to create so you can see. Okay, I'm going to create maybe RealFlow 2015. I'm going to create maybe a bit bigger. Okay, and that's it. Okay, now I'm going to simulate. Where's the scene? I'm going to simulate. Oh, wait, demo effect. Let's try with another scene. Okay, maybe for 2015. Okay, 5. Okay, here we are again. No saving, and now here we are. Okay, so let me show you an example with splines in this video. Okay, the splines are basically in the eyes, nose, and mouth, and they're meeting. Okay, this simulation took 26 minutes only to simulate with 1 million of particles. Okay. But also splines are accessible from Python. So let me show you another video so you can check what is possible to do with the splines. So this hybrid scene is using display demons to create some turbulence with curves imported from 3D Max with a Python script in RealFlow. So the spline demons is creating some turbulence around rocks here. Yeah, and the simulation is cool because it's not necessary to a complex setup to generate that. If you have the curves generated in your 3D platform, you can import with using a script with Python or even from Adobe Illustrator is as SVG format is as you want. Okay. Okay. Let's see. In addition, RealFlow 2015 has the possibility to add text as geometry from this tool here. So I'm going to start a new scene. I'm going to place the same thing. Okay, combine, scale. Okay, it's okay. And here we are. I'm going to okay, that's better. Okay, this geometry can be used as dynamic object, so we can fracture it or filling out with fluid. So let's go to create a diverso domain again, or simply if we want to create the fill emitter, the diverso domain will be created automatically. Okay, And now we need to select the meter and choose the geometry we want to fill in it. Okay, and I'm going this one. Okay, and check the fill volume checkbox. Okay. Geometry for diverso works in the same way as a Hybrido. So we need to adjust the third side for geometry if it's necessary. So if you have the geometry in this way and the particles is not, maybe I'm going to change, sorry, I'm going to change the resolution. Okay, I'm going to hide this one. Okay, now we have a very good fluid inside the text, the geometry text. But I'm going to set the resolution and hide the hybrid particles. If I display the isosurface for this geometry, we see it's not very cool. Maybe it's a bit noisy. So we need to adjust the third side for this geometry, so you can't problems with the geometry. Okay, and now it is better. It's better. Okay, let's try with a few, maybe three. Okay, let's uncheck the surface, and so the particles again. Okay, so we are seeing the tools in RealFlow 2015, and I like very much this one because let us change to make big things as falloffs for demons. Okay, most of force demons are including falloffs to control how they are affecting the particles. Falloffs are working for diverso, Hybrido, and legacy SPH solver. So let's see an example with this thing. So I'm going to create a noise. I'm going to animate the noise, setting a key in the position. I'm going to another frame, move the noise, and set another key. Okay, now it's animated. So if we activate the falloff parameter for the daemon, we can control how the fall is going to affect the fluid. So enable falloff and display falloff on viewport. So I'm going to scale maybe this one, and I'm going to it's this one, edit falloff, this one. Okay. And check the edition mode. Okay, now I'm going to simulate. I'm going to check if the OpenCL is choose and simulate. Okay, sorry, I forgot to connect the noise with the domain. Okay. Okay, now you see how the noise is affecting the particles. So the same thing, for example, for gravity. If we go gravity, display falloff, same falloff. I'm going to copy the transformation between noise and gravity. Okay, and I'm going to say no, I'm going to say that the gravity is parent to the noise. Maybe in another direction. Okay, that's very cool. It's creepy, but cool. Okay, so let me show you a very nice example with falloffs, because this is a very simple scene, but we can open another scene. Yes, and we have this waterfall here. Okay, I'm going to reset the scene to see the particles, because it's an initial state. So imagine we have this waterfall, and we want to apply some extra force where the fluid starts to fall. So we'll place a noise in this area. So I'm going to unhide this one, and let's check the enable falloff to see where the falloff is affecting. Okay, but also we can show the field for this Daemon, and we can check how the force are affecting the fluid. Okay, even I can change the falloff decay type to custom shape and change. Maybe I'm going to add here. See the force I changing, simply adding a different curve. Okay, I'm going to show you the video for this example, this one. Okay, the simulation is amazing. It's only 5 million of particles in this case, but this is amazing, only in adding a noise with falloff. Okay. Okay, what else? The crown for RealFlow 2015. I'm going to start a new scene. Okay, for RealFlow 2015, a new Daemon has been included to create crown effects for fluids on a small and medium scale. It is diverso and legacy SPH. So let me show you an example. I'm going to open a new scene, crown. Okay, here we have a scene with crown Daemon. This is a crown Daemon. The crown Daemon you can find here. Okay, if I simulate this scene, we are going to see that the fluid is affected by the crown Daemon. So the crown Daemon includes an internal shitter, but we can add another shitter Daemon if it is necessary. Okay, even we can modify the shitter this with the edit or edit here. Okay, to change the fluid with in a very simple way. Okay. I'm going to stop the simulation, select particles so you can see the simulation in a better way. Okay, you see that the particles are being affected because Crown Daemon is connected to it. So I told you that you can add a shader if it is necessary to increase the number of particles in the simulation. Okay. Let me show you another sample with the crown. So okay, in this scene, the crown is being activated when the wheel is colliding against paddle. So so if I'm going to show you the the particles, so it's cool because Crown Daemon is very useful to create a lot of effects for fluids. Okay, maybe. Of course, the scene you can. This scene is very simple too because it takes 30 minutes to simulate with diverso. It's very fast to create different setups with the Crown Daemon and simulate to see the results. Okay, I'm going to check edit. So you can modify the spikes. Okay, and the curve like we did before. Okay. Okay, very good. So let me show you a couple of videos or some video more about diverso simulation. It's cool. Okay. Another major feature inside RealFlow 2015 is the openVDB master in RealFlow. Okay, I'm going to start a new scene. Yeah, here. We agree we need a best control about how the mesh is going to be built inside RealFlow. And for that reason, we have included a couple of new meshes, the particle and Hybrido BDB measure, and both based on openVDB to improve the message time and the result. So let me show you an example of this. Okay, we see that with this same setting, Hybrido measure, this is a Hybrido measure, takes almost 10 minutes per frame to build the mesh. And Hybrido BDB measure only takes 1 minute per mesh. That is amazing because it's really saving a lot of time for meshing in a real production. So, but what about the time on meshes? Let me show you another video to show. Here, webinar videos. This scene is a BDB master with Hybrido, and you see the details. There is a lot of details for this mesh here. Okay, close. But how the BDB master works? So if I open this scene, I'm going to open a scene of BDB masses, explosions, and I'm going to show you the particles to see very nice explosion here with Hybrido too. The VDB measure, we have all parameters we had for the previous for the all Hybrido measure, but the Hybrido VDB measure includes filters to control the mesh aspect. So we can add filters. I'm going to mesh these particles so you can see how it's faster to generate the mesh. So maybe from here. Okay. You can see the time here in the console. So, okay, only 9 seconds to generate that mesh. Only this mesh only for 6 millions of particles. So it's very impressive. But the good thing is using volume filters is not going to add some extra time to generate the mesh. So I'm going to add maybe an erode filter. We have a delayed filter, erode filter, and a small filter. So I'm going to add an erode filter, maybe 0.5, and build the mesh again. It's very comfortable to work with the Hybrido VDB measure because it takes very short time to generate the mesh. You see that's the erode filter is affecting the mesh. But I'm going to add another smooth filter. Okay. Imagine we have a delayed filter too. We can change the position for the filters in the window, in this window. Okay, we can uncheck what filter we want. We don't want to use. Okay, and mesh again. Only the last mesh took only 10 seconds, and this mesh 12 seconds. So it's very fast to work with a new VDB measure. Okay. Okay. What else? In RealFlow 2015. We have now a new robust method for creating distant fields for geometry. So I'm going to start a new scene. This new scene. So diverso and Hybrido solvers interact with geometry by first converting that geometry into distant fields. So in RealFlow 2015, that method has some inconvenience depending whether the geometry was ill-defined or causing a bad volume representation, or sometimes we needed to adjust its cell side with very low values for avoiding artifacts, increasing in that way the RAM memory for the simulation. Okay, but if I open this scene, robust method, okay. Now you see the geometry. I'm going to set that geometry with as a cube and display the isosurface for it. Okay, here we have this is important because this message you are seeing is the mesh where the fluids is going to collide. Okay, so we need to adjust to generate the holes and tubes in a better way. So I'm going to sorry. Okay, Now you see that it's still with holes, so maybe a bit lower, maybe 2. But also now you can see the details for the geometry in this geometry. So the distance field on this geometry. Sorry, I'm going to increase a bit the cell size, but you can also play with the surface offset. So you don't need to decrease the cell size with a very low value. Okay, but what's happened with animated geometry like this dragon? Okay, I'm going to hide the geometry. Sorry, the geometry as cube. Okay, the same thing. It's a surface. Okay, now you see that the geometry is pretty good, but we don't have the wings. So let's try. Maybe this is better, but no wings yet. So I'm going to increase the surface offset. Okay, now it's better. This is saving time for simulation also because it takes a short time to generate the distance fields for the objects, for the geometry. So if I go to another frames, it's very fast to calculate the distance fields. Okay. What else? Few time. Okay. The spreadsheet. The spreadsheet. I'm going to open a new scene. Spreadsheet. Spreadsheet. This one. Okay. Here we have a simple scene where there is a spline emitter, and we have a few particles, but the spreadsheet, we need to know what's happening with the nodes inside RealFlow. So when we're working with them, so for that task, we have the spreadsheets. If I click on the spline or the node with right button, I see there is a new parameter. Parameter is called spreadsheet. So imagine we want to know what is the maximum velocity for particles in this frame. So opening the spreadsheet with a simple click, I'm going to uncheck the separate components so you can see the velocity channel here. So with a simple click, I know what is the minimum and maximum velocity for particles in that frame. So click, and now what is the minimum velocity particle? So now I can go the filter Daemon. This scene has a filter Daemon. Filter this one, and set the value for the speed depending on the values we had in the spreadsheet. Okay, I'm going to play the simulation. Okay, that's good. Okay, but imagine we want to change here spreadsheet. So now this frame we have that particles. Imagine uncheck separate components. Imagine we want to know what particles have age greater than 1. So I'm going to make a filter age greater than 1, for example. So and now only I have the particles. Sorry, this one is not working. Maybe. Okay. Okay, now it's working. So the H1 10384, okay, and we have a different H here, and now we can see the particles, those particles in the viewport. Even we can change the H for that particle if I select the H column. So I edit and I add to current value maybe 3, and now I have another value for the H for these particles. Okay. And the last thing I would like to share with you is the RealFlow, the user interface enhancement in RealFlow we have introduced. So we have new icons for the relationship editor, giving a better visual aspect for nodes and very optimized space to connect them. So also we have a quick access to control the display or simulation modes, as well as the data export directly in the node list. So for nodes parameters, we have also the possibility to add or remove keys here, for example, for the position. Displaying, I'm going to remove. If I click on the position to add a key, I'm going to another frame and add another. You can see the keys have been added to the timeline. Okay, but you also have the possibility to create expressions. Maybe we can add a particle mesh VDB, and I'm going to mesh these particles. Okay, so here we are. Here is the mesh. Okay, now imagine you can change the polygon size, or maybe better the spline radius with the polygon size value, depending if the polygon size is changing or not. So I'm going to copy this name. I'm going to select splines. I'm going to set expression with equal and polygon size, for example, 1.51, for example. Okay, now I have the value parent to this to the polygon size parameter. Okay, if I change the frame and I change the maybe this one, I'm going to check, and I'm seeing that the radius is changing. Okay. Other changes, simulation button or reset to initial state button. If I check the reset button, is a dot is appearing here. Now you are in reset to initial state. So will help you to control the simulation as well. So RealFlow 2015 is the easiest and fastest way to make fluids, and I hope that you enjoy this version. And that's all. It's RealFlow 2015, and we try to put the scenes so you can see the videos and scene and play with them to have a better control over them. Okay, so thank you for watching and enjoy RealFlow. Thank you.
Miguel, hi.
Yeah.
Miguel.
Hi.
Hi, great. There's so much feedback to your presentation. Great feedback. Everybody says, wonderful, we can't wait, this is exciting. I have a few questions that have not been answered. Let's see, should we give it a try? Let's
Sorry?
see. I have a few questions that came in that that did not get answered. Should I address them to you?
Okay, okay,
I
yes, of
think
course.
Angel and the Next Limits team did a great job, but there's a couple that didn't, they weren't addressed yet. So let's see. Will you guys ever work direct with VUE?
DUE.
VUE?
Uh, VUE.
VUE?
Yeah, no, it's now it's not possible to work with. We don't have a plugin yet for VUE.
Okay.
Uh,
Okay, and
but
somebody else, yes, go ahead.
sorry, maybe if VUE has Alembic files, it's possible to work between RealFlow and VUE because RealFlow is able to export to Alembic files.
Okay. Let's see. Let me see. See what if there's any question that I was not. I think that's it. I think everybody is excited. The team did a great job, addressed them all. And the question that was asked a few times was, when can we get our hands on RealFlow 2015? And give us a date, ballpark.
Sorry, I can
Everybody
hear you.
asks, when can we get our hands on RealFlow 2015? When can we buy
Okay.
it? Yes,
Yeah,
everybody wants it, and they want them now.
yeah. It's will be released at the end of this month.
Okay, great. Does all the daemons work with diverso?
Yeah, not all, but the most of force demons are working with diverso. It's maybe there are a couple of them is not they are not working with diverso, but yes, for the most of demons.
Great. And are there any changes to RealWave?
Not yet, not
Okay.
yet.
Okay. Okay, fantastic. I'm sorry, but I will have to take the screen back. I'm sorry to disappoint everybody. So I'm going to have to wrap it up and take the screen back. Let's see. Let me know if you can see
Yeah,
my screen.
I can. No, I can see. Yeah, now.
Okay. I don't know why I can't enlarge it. But anyway, I would like to thank everybody for attending this fantastic webinar. And I also want to remind everyone to visit our page at noveg.com and check out RealFlow 2015 coming out at the end of this month. Stay tuned, we'll announce it, but please come see if you can, you know, find it before we announce it, and give a check now and then. You won't miss it. For information on the latest special and new releases, join the Noveg network on Facebook, Google Plus, or Twitter, and subscribe to the Noveg blog. And don't forget, we have a special webinar tomorrow, Autodesk Mythbusters, where you can find out all about the changes going on with Autodesk and the impact this will have on your business. To rewatch today's webinar or previous ones, check out our Noveg YouTube and Vimeo channels. Our webinar playlist has webinars for every software taste, and as early as tomorrow, we'll have this presentation uploaded. So I know some of you had to leave, put the kids to bed, but don't worry, we'll have it on our YouTube channel there for forever and ever. Thanks again for joining us. Have a wonderful day. I want to thank again the Next Limit team. And I want to say adios, everybody. Bye, Miguel Angel. And Thank you so much for a fantastic presentation and for being so thorough with all the improvement of RealFlow 2015.
Thanks to you.
Thank you. Bye-bye.
Bye bye.